My name is Rohan Goswami, and this is my solar water desalination project. Over here, I have my completed water desalination project. To make it, what I did was take 1 cup of water and I placed it into a container. In this case, I'm using a Pyrex glass container. I then add half of a teaspoon of salt. These are 1/4 teaspoons right here, so I'll add 2 of these. I dissolve the salt into the water. Salty. I then place a smaller container into the large container in the center of my original bearing container. After doing so, I took 1 sheet of plastic wrap and placed it over the container. This acts as a surface in which the water evaporates. It will recondensate and form water droplets. I then put some weights at the top as a point that will allow the water droplets that condense on the top of the plastic wrap to float into the vessel. I then took this vessel and set it outside in the sun, which out here in Southern California, I left it for about 3 hours. The end result was what we have here. What we have here is my completed solar water desalination project. As you can see, we have condensation from the heat that was acquired from the sunlight the 3 hours it was out. This has led to the accumulation of water now in the center container. I have already pre-measured this water before starting this video to make it a little bit more time friendly, and it came out to about 2 teaspoons of water. Tasting the water, it remains completely unsalty, similar to that of a regular cup of water. What we did was, the sides are still fairly salty. The way this process worked was through a method of radiation, which came in and it heated up my container. By heating up the container, conduction took place and it warmed the water that laid in the bottom. By warming the water evaporates. By evaporating, it condenses against the plastic wrap at the top. The weights bearing down create a central focal point in which the condensation droplets will drop into the container in the center. During the process of evaporation, because water evaporates and salt does not, the salt remains behind, leaving pure water in the container. This is a method of cleaning the water. Additionally, a little bit of convection happens in the container. As we know, convection, warm things rise and cool things sit towards the bottom. By allowing the warm water to rise from the conduction at the bottom of the container, my water evaporated more freely, thus dissolving into a gas, condensating on the top of the plastic wrap and falling into my container. Here, as I said before, we had about 2 teaspoons of water, which comes out to the equivalent of about 10 milliliters. In this 10 milliliters, we originally had a volume of about 236 milliliters. When calculating this out, it comes to about 4% inefficiency. So it is a fairly inefficient process. The water inside is, as we said again, had no salty taste because the process of evaporation leaving the water behind at the bottom of the pan. I do think that the size and shape of the container would play a factor. A larger container would provide more surface area, and it would allow more water to evaporate in a smaller given amount of time. By allowing more surface area, more of the water is evaporating to the top and condensating and dropping into the smaller vessel in the center. Additionally, I think depth would play a factor in the case of time. By having a smaller water depth, it requires less time for the water to heat up to a point where it reaches a evaporation temperature. The more water we have in here, the more we can actually generate over a longer period of time. But in a short period of time, if we just had a shallow depth of water, it would heat up faster and condensate faster, thus falling into our container a little bit faster. The improvements that we can make to this container, I realized after conducting the experiment. By using containers such as this, it has reflective edges which will concentrate the sun's rays, thus allowing the water to heat up faster. Another thing that we could do is some pans have a black absorbing bottom. This absorbs more heat, thus allowing more conduction to go from the bottom of the pan to the water itself. So by having a pan with a black heat absorbing bottom, as well as reflective sides such as this, we would have a case where I think we would be able to generate a little bit more water than the efficiency of 4% that we yielded in this water desalination experiment. Thank you.